Our next presenter is Paul Ura. Paul Ura was born and raised in Austin, Texas, and received his Bachelor of Science degree in meteorology from the University of Oklahoma. He joined the National Weather Service in 1992 and has worked as a meteorologist and forecaster in Norman, Oklahoma, Brownsville, Texas, Charleston, South Carolina. Paul became a warning coordination meteorologist in 2002 and has worked at the Austin-San Antonio National Weather Service office since 2008. Paul's primary job is to be a liaison between the National Weather Service and local media citizens, county, state, and federal agencies. He conducts storm damage surveys and leads the community outreach program. Please welcome Paul.
Thank you very much. Is my microphone okay in the back? Can you get that? Okay, excellent. Okay, so today we're going to be talking about some outlooks. Outlooks, basically information, websites, information that you have access to when you're trying to do your planning. Especially we're going to be talking about the outlooks that include drought, flooding, fires, and then also winter weather, or we consider ice. Like she said, I kind of grew up here in Austin. I've been in the Weather Service is the only agency I've ever worked for, so I'm 32 plus years. The National Weather Service, I actually started my career working at the small Weather Service office that actually was located in Austin by the old Miller Airport, if you're longtime residents of Austin or kind of know the history of Austin. But I'm going to keep it pretty informal. Hopefully we'll have some time for the questions at the end. I'll try to get as specific as possible with some of your forecast questions, not knowing exactly where you are from and what the forecast is for your part of Texas. I'm in the New Braunfels office, which has 33 counties of jurisdiction, basically right where we're at, middle part of the state. So I know this forecast the best, but as you can guess, it's going to be hot and dry for the next week or so. So hopefully you enjoy the very cool July and the rainy July in a lot of parts of Texas, because now we're back to the brutal part of what summer is supposed to be in August and so forth. If you're not familiar with the National Weather Service, we are a federal agency. We technically get our funding from the Department of Commerce, and then a section of the Department of Commerce is NOAA, the National Oceanic and Atmospheric Administration. Consider us the atmosphere part of NOAA. So we do get our funding from federal dollars coming all the way down. As an interesting kind of little tidbit, each citizen in the United States for our funding, $4 an entire year. So each citizen, $4, that's basically our budget in the National Weather Service. So relatively cheap if you consider pay $4 a year and you get the National Weather Service and all of our warnings and forecasts for $4. We are the primary source for weather, hydraulic, river forecasts, climate information across the United States. Of course, there are private weather forecastings. You know the Weather Channel, AccuWeather, some of these other apps that you get. Those are private meteorology groups, but we are the federal agency that provides all citizens with weather forecasts and weather watches and warnings. And then finally, we do have 13 forecast offices in the state of Texas. Texas, how many counties in Texas? Anybody know? 254. So there's a lot of counties. And so in this graphic kind of shows the jurisdictions of our National Weather Service offices in Texas. So when we talked about my jurisdiction, I'm here in the orange area. Our office is in New Braunfels, Texas. But you can kind of see that we have offices throughout the whole state, nearing us, San Angelo, Corpus Christi, Brownsville, Houston. And then we have offices that are outside of the state of Texas that have jurisdiction for parts of the Texas counties. So Lake Charles, Louisiana, Shreveport, Norman, Oklahoma, and then even technically El Paso office is physically in New Mexico, but has obviously counties in Texas itself. So a lot of dedicated people. Our offices are not very large when it comes to the amount of employees. We have about 25 people per office, 24/7 operations. So as an example, when I get back to the office this afternoon, there will be 2 people in the office. And then in the overnight shift, there will be 2 people left in the office. And then day shift comes around at 7 a.m. And there's some more administrators like myself come in, support staff, technicians, and so forth. But we're staffed bare bones. We're staffed to handle normal weather events. If we know a big weather event is upcoming, we have to staff up with overtime and people on days off and everything just to handle the workload and handle the weather situations that we typically have. I forgot to mention too, besides these forecast offices here, we actually have 3 river forecast centers, one being in Fort Worth and the other 2 actually being out of state. But instead of counties, the River Forecast Center forecasts for watersheds. So obviously that cuts across county lines like that. So let's try to understand some of the weather forecasting and what we do and what our job is throughout the day. Typically, when we talk about short-term forecasts, we talk about time 0 now out to 3 days. So that's when we're using a lot of weather models and so forth. A longer term of that is the medium range forecast, and that goes all the way out to 14 days. Now, officially in the National Weather Service, our official forecast goes out 7 days. We technically, on our website, you cannot find an official forecast with the chance of rain and the high temperature beyond 7 days. If you watch television, you'll notice that some TV meteorologists actually go way beyond 7 days now. They're putting up a 14-day forecast. We have some of them actually doing a 21-day forecast. You're now, that's a shotgun blast that's very wide, right? Because you're using a lot of now climate, and the weather models don't perform very well when you get beyond that sort of range. Then we have long-range forecasting, which really ties into the climate and the climatology. Climatology is a whole other science. I took a class in climate, but I am not a climatologist. I am a meteorologist. So I specialize kind of in the first, now to the 14-day sort of range where the weather models are really kind of, looking at some stuff that I can kind of follow. But beyond that, you're talking about very, very long sort of climate sort of forecasts, which we'll talk about. Those are the outlooks. So in the short-range forecasting, we're talking about the chance of rain tomorrow, the high temperature tomorrow, and if we're issuing any sort of watches or warnings, the real dangerous and significant weather events that happen. In the medium range, this is where we're looking at beyond the 3-day range. During tropical season, right, we were looking at Beryl, way in the Caribbean when it was a Category 5 hurricane. And so we were looking well beyond 7 days to kind of see where Beryl was actually going to go. And then these long-range forecasts are what we call the seasonal outlooks. This is where we can technically go up to a year out and to see during what season are we expected to be drier than normal, or wetter than normal, or hotter or cooler than normal. As you can imagine, making day-to-day plans 4 months out is a tough thing to do. And believe it or not, yes, we have people, especially brides, that will call and ask, what is the weather going to be like? Literally 5 months from now on that particular day. As you can imagine, I'm pretty wishy-washy with my answer. I'm not going to give them a direct, this is how hot it's going to be. What I can do, though, I can pull the climate data from the last 30 years and tell them what the temperatures have been for the last 30 years on that particular date, and if it's rained, to give them some sort of range, right? And that's kind of what these outlooks do. They give you a range of kind of maybe what to expect, but it's not going to be forecasting our extreme events. It's going to give us an overall average of what we think the weather will be like months from now. Those are called the outlooks. So when it comes to weather forecasting and what our job is as meteorologists, we're at our office, we have all these fancy weather models. What are we looking at? Well, it starts with observations. A lot of you that are familiar with your water systems and so forth and your rivers, there's river gauges, there's weather instrumentation at airports that we use. Private citizens have got little weather stations. All that data gets dumped and is shared basically worldwide almost. Weather is a science that is shared worldwide because it's needed, especially for aviation, right? Pilots flying cross transatlantic flights. You need to be able to know what the weather is when you're landing here in Austin if your flight is coming from Germany or London, let's say. All right? So all these different ways we can actually get weather observations from boats, from our Doppler radars, from satellites. Right now, the Hurricane Center, when they're flying those hurricanes, they're dropping weather instruments into those areas. The state of the science affects our forecast. When I first came in, and this kind of goes to the computing power, we had weather models that were generated twice a day, and we had 2 weather models. There really wasn't much to choose from. You kind of went with your gut, your experience, or you kind of looked at these 2 weather models to kind of see maybe which one you thought was maybe best. We now, because of computing power and supercomputers, we now have models that are run hourly. And so literally we can check the weather models hourly, some of them, not all of them, but now we're also looking at the American model or the European model and the UK Met model, and the Canadians have a weather model. Private universities have got weather models. So all these different models and data that we can look at is really kind of affecting how we do things. And then one of them too, what we call teleconnections. What's happening elsewhere in the world can affect what's going to be happening here, especially in the United States. So there are things that are connected worldwide. The atmosphere is a fluid. You may not realize that when you walk outside. That's actually a fluid, and everything is behaving like a fluid, just like the ocean waves. So when things are happening and big waves are happening over Asia and the Pacific Ocean, eventually those waves will make it to the United States. And so it's that sort of connection that we kind of try to follow to kind of really give a good idea, maybe in a couple weeks from now, what kind of weather are we going to be expecting. So a little bit more about these teleconnections. Think of it kind of as a seesaw. What happens over Siberia in the wintertime may eventually trigger something to happen in the United States or on this side of the globe, and vice versa. Something is happening over, say, the tropical Pacific. How will that affect kind of weather somewhere else on the globe? And sometimes they're easier to see than others, and there's some teleconnections that we talk about more than others. One, I'm assuming most of y'all probably heard the term La Nina and El Nino. It's kind of plastered in media, and the weather folks on TV talk about it a lot because that is one of the more popular ones and ones that we know the most about. And so we're going to talk about that. Officially, we call that the El Nino Southern Oscillation. We call it ENSO, but a lot of you know about El Nino and La Nina. So let's kind of talk about it. When we're talking about La Nina and El Nino, we are tracking the water temperatures in the tropical Pacific region, so around the equator in the Pacific Ocean. If the water temperatures are colder than normal, we call it we're in La Nina conditions. And if the ocean waters around the equator in the Pacific Ocean are warmer than average, we call that El Nino. And you may say, like, well, so what? Well, you guys know how much water covers the Earth's planet? It's up there. It's like, what, 70% or something like that. So if you're changing the temperatures of a massive body of water that encompasses a huge percentage of the Earth's surface, that is going to change the atmosphere. And so even just temperatures of 1 or 2 degrees Celsius above normal can drastically change our weather patterns across the world. And so that's why it's important for us to track ocean temperatures, not only here, but in the Gulf of Mexico and in the Atlantic Ocean. It's because all that is tied together. The ocean drives the atmosphere, and sometimes the atmosphere drives the ocean. They play off each other. And so it's that connection that becomes very, very important. So how does this kind of lead into our droughts? And the good question is, too, what is a drought? We'll have media call up all the time and say, when did the drought start? And we're like, I can't give you a date and time, right? Because a drought is, it kind of get into a drought. It doesn't just start. I guess technically you could say it started the last time it stopped raining, I guess, if you're in a long-term drought. But it's a very hard thing to visualize and to put a date and time on. When did the drought start? Because to some people, the drought may be, when did the creek stop flowing? And the others may be, when did I have to start watering the grass a lot, right? It depends on the person. It depends on what you're kind of using as a definition of drought. Now, technically, it's the absence of precipitation. That's kind of easy to remember. But it's also, again, very difficult to define and then monitor because there's different types of drought. So, but obviously, there's a lot of different effects to drought, and that's primarily what we try to track, even within the National Weather Service and for our climatologists, is what's being affected by the actual droughts. There's a listing of kind of some of the types of different droughts. Now, I'm most familiar with the far one, the meteorological drought. How much rain have we had, or when is the last time it has kind of rained? That kind of stuff is pretty easy to find because you go to some of the websites that have rain gauges. You can see how far below average we are, and we know we're probably 10 inches below normal, so we're probably in a drought or something, right? There's also the hydraulic droughts, right? How low is the river? How low is the lake? How low is the aquifer compared to normal, right? Those have different drought conditions. Agricultural drought, socioeconomic drought, where we talk about the demands on commodities. One of the big things that's happened, I think it was last year or the year before, I forget, the Mississippi River was so low, right? It starts to affect navigation. How quickly they can get some of the boats down to where they need to drop off their commodities and stuff. So yes, even large stem rivers like the Mississippi River can be affected by drought, especially if they don't have the amount of rainfall that they need further upstream, like into the middle part of the United States. So a drought in one part of the country could actually cause a kind of a socioeconomic or even a hydraulic drought somewhere else in the country just because that's where the water comes from. So again, some of it is really tied together in that sort of time. Some other impacts that we get from droughts, I'll kind of talk about this one down here the most here, right? The water quality one. As you can imagine, as you get decreased amounts of rainfall, decreased amounts of water flow, then you start talking about different water quality levels, right? Things that can happen to your water quality just because we don't have the normal amount of rainfall or we haven't had rain in quite a long time. Public health concerns, of course, agricultural concerns. I talked about the transportation concerns, especially the supply chains of ships and barges that are trying to navigate some of these larger main stem rivers that don't actually have a really good flow because they're in drought. And then finally, wildfire. We're going to get to wildfire here in a second, but especially here in this part of Texas, and actually most part of Texas, as soon as we start seeing those droughts and the drought severity start to increase, what do you tend to see? You tend to start to see some of the fires start to pop up. So that's obviously a very, very big impact from droughts and what we call now flash droughts, droughts that start very, very quickly. Is almost an instant fire weather concern, especially around in areas in here that don't have very deep soils, that the soil moisture just goes away very, very quickly, and before you know it, you have fires because it hasn't rained in 2 weeks. That's literally how fast some of these wildfires can start up. We do try to monitor drought conditions. And again, most of it, at least from our end, is monitoring aquifer levels, rain gauges, rainfall, and see how far behind we are in some of those areas. And because of that, and with that, we look at then the drought impacts that happen, and then also get feedback from local experts to kind of figure out what level of drought are we in. They don't just say we're in drought or not drought. There's different levels of drought now, and we call that the drought monitor. You may have seen this before. It's on some different websites. It's on the National Weather Service website. In fact, this is updated actually every Thursday every week, where across the United States, local experts gather, state climatologists for Texas, of the National Weather Service offices. We look at all of those, how much rain has happened over the past week, what are the water levels, what are the lake levels, and try to figure out how bad is the drought, or do we have any drought at all. So this was a map from about a month ago, and you can kind of see that East Texas, because they'd had some pretty decent rains in the first part of the year, did not have any technical drought conditions in there now. I just looked before we started, and from July 9th to about now, some of this has improved. Because we had a pretty wet July in this region of Texas that did kind of go a little bit closer to the Rio Grande, these levels of drought have actually gone down about one category. We still have them out there, but there has been improvement. So just to let you kind of know, like in my yard in Comal County right there, my grass is as green as I've seen it in years. But our lake is still record low, Canyon Lake. So we still have a drought, although visually in my yard it's like, well gosh, I don't have a drought locally because my grass is as green as I've ever seen it. I haven't even had to use my sprinklers yet this year. So again, it's not one simple answer sometimes. And with the droughts then, we can provide a drought outlook. What in the weather patterns does it look like? Are we going to get out of drought? Are they going to get worse? What's going to be happening? You can see kind of in Texas here, in the darker kind of brown, drought persists. So we don't see anything in the long-term weather patterns to think that we're going to have a really, really wet West Texas over the next couple of months. So we think, we're in the middle of summer doldrums already right now. What's probably out there is probably just going to persist. This area here was highlighted in kind of parts of the Panhandle and also Oklahoma. Drought development likely. This is where we're having now a flash drought. We think because of really extreme hot temperatures over the next couple of weeks, no rainfall, we think that area is going to be prime really, really quickly for what we call a flash drought conditions happening and developing. Plus then also what's going to happen with that then is wildfire conditions very, very quickly in that region of Oklahoma. So, and then this area here out in the, kind of some improves drought overall removal likely. So the rainfall pattern of probably Debbie and all the rainfall that they're going to be getting, they're kind of thinking that we're going to have some improvement in that sort of region. So again, scientists looking every week to this kind of stuff, seeing where is it getting worse and where is it getting better. Now the problem of too much water. Doesn't happen a lot recently, especially in this part of Texas, but these are all the different ways we can kind of get flooding concerns. Obviously intense rainfall, that's kind of an easy one. Rain over several days. So as a meteorologist, I've worked at plenty of those sort of different events where we weren't expecting heavy rainfall overnight, and one thunderstorm just sits there and dumps all that rain, and we get a big flash flood. And then others are these more long-term 2 days, 3 days worth of rainfall, the rain over several days. We could have flooding from a dam or levee failure. If you live along the coast, we could have just high tides, storm surge, wind pushing the water onshore, like from a tropical system. We could have snowmelt, and then also in other parts of the country, they get flooding when the winter ice starts breaking and melting, and then also jams. It's a debris. It's debris in the river that backs up water, and you can actually have ice jam sort of flooding too. So don't get obviously a lot of that in Texas, but we do get a lot of the others when it comes to ways we actually get flooding. Closer to kind of home, when we talk about rainfall, let's say you're in East Texas or around the Houston area, you may be getting more of the pond or street flooding. Right? You're not part of a creek system. There's no creek in your yard, but yet somehow you still get all this water to kind of pond up. We here around the Austin area get a lot of what we call flash flooding. This is very fast-moving water, very dangerous. We lose most people to vehicles getting swept off the road. That's historically how we lose our folks here in the Austin region for flooding. Then if you live by a very large stem river or a creek, we can have just strictly river flooding. Maybe water fell 50 miles upstream, but yet your river is flooding and you have to evacuate homes just from, didn't even rain anything here, but the rain fell from upstream. So a lot of that can happen. And then obviously coastal flooding too, with high tides and also wind pushing water onto the roads. We do have some guidance for you out there too, water system, and you're trying to look to see what kind of outlook there is for every sort of heavy rainfall. We call this the excessive rainfall outlook. Is from our Weather Prediction Center. And so this was from several years ago. Kind of looks like what it would be almost today with Tropical Storm Debbie out there. But they highlight areas where there's a high, moderate, or slight risk of excessive rainfall. Rainfall that will likely be causing flooding out there. So it's a great situational awareness tool, but what it is not is an idea of where specific flash flooding will happen. It's a very broad brushed sort of look as to where are the conditions setting up for a lot of heavy rainfall. So you have to kind of think of it that as a 30,000 foot level product of, okay, this is where the heavy rain will likely occur over a region. We issue flash flood watches and flood watches. Sometimes we can issue flood watches if we know the conditions are going to be good, if we know the soil is wet, there's a big rain system coming in, we're going to get 3 to 4 inches of rain, we may issue a flood watch. Maybe we issue the flood watch before the rain even starts, literally like the day before. So we can issue it way before the onset of the event. And then as we're going through the event, this is where some of the other products that the National Weather Service can actually issue. Flood advisories for, I would say, more nuisance flooding, street curbs, some parking lots, maybe a couple of low water crossings in your community kind of go flooding. That may be a flood advisory. The warnings are always the most important product we issue. They are the imminent threat to life and property type of products. Okay, so if the river is flooding, then that would be a river flood warning. If a flash flood emergency is happening, this is our worst of the worst products we could issue. This means catastrophic flooding, massive loss of life, and massive infrastructure loss. So Houston has had a bunch of these. Here locally, 2015, the Wimberley flood. Those are some of the floods and we've had some in Austin here too. So those are the floods that I remember as my career as a Weather Service employee. I remember what that night was all about. And it was that sort of flash flood. So these are the events that you remember and then you take away from years and years and years. And there's also a lot of infrastructure loss and there's a lot of recovery for years and years and years with the state, FEMA, et cetera. So as the potential increases, this is the danger increases as well. This is a good kind of image of what river flooding is. Depending on what kind of river you're living by or what river goes by through your community, it could look different. Out in the hill country here, the rivers go through canyons. They've literally cut through the limestone hills, and so they're very high-walled sort of rivers. As you get east of Interstate 35 here, as you get to East Texas and the coastal plains of Texas, that floodplain spreads out and gets low. So these rivers, as they go out of banks, can be upwards of 1 or 2 miles wide then. So different types of flooding in different parts of the state. In the hill country, the rivers and the flooding moves fast. When it gets east of Interstate 35, east of the hills and the flatter terrain, it slows down and it widens out. With these different sort of river floods, we have different categories of how bad will it be. So a lot of these are action, minor, moderate, and major. As you can imagine, major impacts are you're talking about homes being flooded out. evacuations, portions of infrastructure being flooded out. Major river floods don't happen too often, but we had a whole bunch in East Texas earlier this spring. A lot of those rivers had way too much water in the lakes, and the lakes were pushing water through because the lakes were overflowing. And so the Army Corps of Engineers, especially with those lakes, were just trying to navigate that water downstream as best they can. Eventually, yes, they're going to go out of banks, and you're going to have flooding like that. Different rivers have river gauges on them. Not every river has gauges all up and down the river. There's just some of them out there. But the river forecast centers will issue the forecast of how high the river will get at those certain locations. The longer range outlooks that we actually get from the Climate Prediction Center, again, more climatologists kind of in there than I'm as a meteorologist, but they'll sometimes look out 3 months ahead of time. How bad will the weather be, or what kind of weather are we expecting seasonally? And so these come out typically every month. They'll go out an entire year. So yes, on the website, on the CPC, Climate Prediction Center website, you can look to see, as of right now, what the forecast is for December. And you can see if our temperature is expected to be above average or below average, and what the precipitation will be. Now again, are you going to be making operational plans right now because of a forecast 6 months from now? Probably not, but it may give you an idea of what's kind of headed that general direction. When we talk about fire, great picture here. This is of our Bastrop fire back in 2011. 2011 in Texas was our driest year in Texas history. Most of the state was in some level of drought for a big chunk of the year, and especially the extreme sort of drought conditions. So the fires that burn out of control in a natural area that include forests, depending on part of the state. On East Texas, you have a lot of forest type of wildfires. In the Panhandle, you have a lot of grass type wildfires. They can spread quickly, and of course they can destroy homes and everything else that comes with that. To get them, you need a spark first. The spark can be natural. Lightning from thunderstorms can actually start wildfires. But you can also just be heat from the sun. It can be a lawnmower on the side of the road, or it could be a chain being dragged on a trailer. All those sort of things have started wildfires before. You need a lot of fuel, which is typically dry brush and grass and so forth. And then you get that fire. And then depending on the weather conditions, will then determine how fast that fire spreads. Windy conditions, dry humidities will all kind of lead to very, very explosive fire growth, as what we call it. So the speed of the wildfires, some of it is from what we call spotting. I know this when we were watching and working the Bastrop fire back in 2011. The plume was so large from the fire that new fires were starting 4 and 5 miles downwind from the actual fire. So that's what we call spotting. So that enables it to move very, very quickly because it's literally creating new fires downwind where the wind is kind of falling some of the embers and so forth that is pushing downwind. The fuel type, again, is very, very important. Drought conditions really kind of amp all of that fuel up. And then even topography, especially as you get to Colorado and some of the mountainous areas, that really becomes key on how the firefighters fight the fires, and then also its own weather conditions that they create. So these fires get large enough that they do create their own fire conditions, their own wind regime, their temperatures and everything else sometimes. So it's like a little mini weather system that they create because it's such a massive sort of fire. We actually have meteorologists that will fly out and deploy to the large forest fires, work with the Forest Services, give them the forecast, be in the tents and do the briefings in the mornings and give them an idea of what sort of weather conditions are expected on those particular days. The red flag warning days for here are the worst. That means that conditions are going to be right to getting wildfires. Now, in Texas summers, there's a lot of just dry, hot days. Not every day is a red flag warning day. We have certain criteria. Typically, like humidities below 20%, wind gusts 15 to 20 miles per hour are some of the local criteria that we use. If we meet those criteria, that gives everybody the heads up of just we're in a dangerous condition for starting fires on a particular day. These longer range outlooks can actually help us then to determine what kind of fire season we are going to get, especially for the La Nina and El Nino conditions. La Nina historically in Texas gives us drier years. So when we're in La Nina, which we had been about 2 years ago, we had 2 years of pretty decent drought in all of the state of Texas. El Nino tends to give us wetter conditions, especially in fall and winter, like we've just had. Right now, the forecast is for us to go back into La Nina. So the unfortunate part, especially for my region, is that a lot of the lakes did not get enough water during El Nino conditions to really make a good effort in getting those numbers up. Now, we can still have tropical systems hit, we can still get rainfall plenty of different ways, and so that's what we're going to hope for, especially to fill some of our lakes that are still very, very low out there. It's called the Predictive Services of the National Interagency Fire Center in Boise, Idaho, actually has longer-term fire outlooks. Remember I talked about the drought conditions kind of increasing in Oklahoma. They're already kind of highlighting this for August and then also in September, where they think that the fire conditions are going to be increasing in that sort of region of the United States because of increasing drought, but then also lack of rainfall expected. When we talk about ice, we're going to be talking about winter weather. So ice is a very generic term, but from this point forward, we're going to talk about it just as what we call winter weather. Percent of winters with measurable snow. Snowmageddon was that week right around Valentine's Day and everything else that was just one that we're always going to remember for multiple different reasons. So the cold temperatures and precipitation, typically October to April. It is, especially according to this map, if you're along or north of Interstate 20, you'll probably see measurable snow once per year or once per winter time. As you get this far south, East Texas, Central Texas, South Texas, it becomes much more uncommon to actually see snowfall kind of forming. But this winter weather can be in a form of rain, freezing rain, sleet, or snow. And so bear with me. I'm going to try to teach you really quick why it doesn't snow here a lot. Okay? It all happens to be, where is the warm air? If the warm air is from the ground all the way up to cloud level, that's a big enough layer of warm air that the snowflakes will melt into raindrops. Okay? So we get a lot of cold rain events, especially like in this portion of Texas. If the warm air layer is kind of right in between the clouds and the ground, let's say it's freezing, let's say it's 29 degrees here, but it's above freezing in this little layer of a couple thousand feet, the snowflakes will melt into raindrops, but then they'll refreeze on contact. And so that's kind of like your freezing rain. If it's higher up, snowflakes will melt into little raindrops. The raindrops will freeze into those little pellets that bounce when they hit, right? And that's what we call sleet. And then if it's cold all the way up like it was during Snowmageddon, we get snow that actually comes all the way down. So the further you go north in the state of Texas into the Central Plains, the cold is all the way up to cloud level. And so you just have more snow. As you get further south into the state, that layer of cold air gets skinnier and skinnier and shallower, and you get a lot more freezing rain and sleet and everything else. So it's a challenge to figure out if you're going to get ice like freezing rain or if you're going to get snow like everybody kind of wants. Because snow is a little bit easier to deal with on a lot of different things. We do issue different products during wintertime. Typically, if we think we're going to get some nuisance type of travel issues, we'll issue the winter weather advisory. Everything's probably still open. The overpasses may get closed down because those ice over first, right, the overpasses. But everything else is pretty much open because we're just going to be a little bit of freezing drizzle or a little bit of snow. As we get into the winter storm watch and the winter storm warnings, that's where the impacts, warning, that name warning is our most impactful product. That's where things are closing down. So much snow, so much ice is going to be accumulating that things are, all right, ISDs are closing down, infrastructure is going to be shut down, power outages start increasing. So that's going to be a bigger impact on your sort of region as we get into the winter storm warning. So again, it is tough. In areas where we have terrain, as an example here like in Austin, west part of Austin may be below freezing and we have them under a winter storm warning. One county south of here is just getting cold rain at 34 degrees. So it may be very localized depending on your topography and how cold your temperatures are also. So it's a lot of excuses to why you shouldn't get mad at the National Weather Service and the meteorologists. We really do our best. We really do. I promise you. But it's hard when these pockets, and when you're driving the car, you can see there's pockets of cold air, right? The temperature drops in on your thermometer in your car. You know those little pockets of cold air are out there, and that affects if it's going to be ice or something else. So the winter weather, typically we talk about, these were the seasonal outlooks from a couple months ago, how we looked at December, January, and February for this upcoming winter. And they're already kind of showing us above normal temperatures and then below average precipitation. A lot of that goes right to we're expecting La Nina conditions. So right now, this is the forecast for our winter. Again, that could change in a couple of months, but if La Nina really develops, we probably won't see much difference of this. The issue is those maps kind of look the same as these maps, right? Above average temperatures, below average precipitation. Guess what year this was? February of 2021. So just because you have outlooks, monthly outlooks that say it's going to be warmer than average, that doesn't mean that you can't have snowmageddon. Now, if you remember that winter, if you take out those 10 days of snowmageddon, it was actually a pretty mild winter across much of the state. But everybody remembers that 10 days of you know what? That was nasty. But so these outlooks, they can't find those small little weather events in there that sometimes happen. The flood events, the freeze events, the flash droughts, all that stuff is hidden in the longer patterns like that. And this is just a couple of pictures of what happened during Snowmageddon. Because it's so hot outside, why not talk about when it's cold? Every 254 county of Texas was under a winter storm warning at one instant. Every county in the state of Texas. Had never happened before. I mean, even the valley was under a winter storm warning, right, because of all the ice and the cold and everything else. These were the power outage images. This is 2021, the day before on the left, and the day during the actual event. As you can see, all the power outages in portions of Houston. I think everybody kind of found out what grid you're on in the city, right? It's like, I'm going to live by a hospital next time, right? Because you're anybody hear about all the turtles? It was one of the biggest turtle issues that I've ever, like they got shocked by all the cold weather. And I guess a lot of them wound up dying and everything else. So at least from that sort of standpoint, it was a really big impact for the Texas coast and all the turtles that tend to give birth and everything else on the Texas coast. These are just some of the big events that we actually had during the February and winter of 2021 around the United States. And here's our big cold outbreak listed here with the snow and the ice and everything else. So outlooks do not capture extremes. This is kind of going back and looking at the mean temperatures for February of 2021. Again, Snowmageddon. Yes, we were below average in temperature, but that map does not do it justice of actually what happened in the state of Texas. And also with the precipitation. We had all that snow and ice, but overall, the precipitation was actually below normal. So again, outlooks, use them for what they are. They're future, and they're kind of bigger pattern, but those certain weather events that could affect you locally, big time, usually don't show up in the far outlook sort of forecast that climatologists use. So wrapping it up, again, teleconnections, things happening in one part of the world can, yes, affect us. The long-range outlooks are available for planning purposes. I would use them just as that. Remember my little story about the bride, right? Trying to get the weather for her date of the wedding. And they do not capture the extremes like that. So, questions about weather or anything else? The question is there anything realistic about weather manipulation? Believe it or not, I'll do the easiest answer really quick. You've probably heard of cloud seeding before. Cloud seeding technically still exists. It is not as prevalent as it used to be. A lot of places in the western United States still use cloud seeding, especially to try to get increased snowpack. What you find less and less now are companies that actually cloud seed to try to get rainfall like from thunderstorms. There's actually a company in Pleasanton, Texas, just south of San Antonio. It's been there for, gosh, I think a couple of decades, that still cloud seeds. People buy into it. It's a cooperative, and then they try to make it rain. Now, you can't fly an airplane and put out the little chemical that they do and create rain on a day-to-day. You already have to have rain showers and thunderstorms already there. What you do, you enhance the rainfall when you cloud seed. So, correct, more efficient is what the science kind of shows. So, I mean, it does exist. It just does not happen as often as maybe it did a couple of decades ago, at least from what I understand. Typically, weather patterns, we always watch the news and storm systems hit California first, they cross the Rockies, and they go to the East Coast, right? So depending on your latitude of the globe, the jet stream, which is kind of the highway where the weather systems travel, yes, goes from west to east. As you get closer to the equator, it shifts. If you ever watched that movie Castaway with Tom Hanks, he waited for a certain time of year where the flag switched at his island so he could try to get off that island. the winds will shift. So like down in Brownsville, as an example, during most times of the year when we launch the weather balloon, we'll see winds blowing from west to east. But in the summertime, there is a shifting of the trade winds. And that will shift, those easterly winds will then kind of come further north. And so that's what we're seeing with the Saharan dust, with Beryl that formed. All of those are then kind of latching on what we call the easterlies. And they then, on that time of year, in our summertime basically, will then start to move east to west. So in Michigan, you're never going to get easterlies coming in from like New York City, right? They're too far north. But in the southern latitudes, there is a shift of the main upper level winds that does happen. So it's a natural process. It's a natural process.
Okay.
Okay.
Thank
Have
you.
a good afternoon, everybody.